we'll be solving this perfect square question. So before we move on to question, let's just look at what that's saying. Given an integer written the least number of uh, perfect square numbers that sum to n. A perfect square is an integer that is square of an integer. Integer that is in square of an integer. Alright, like 4 is a perfect square because it's square of 2. 3, 9 is a perfect square because it's square of 3. And in other words, it's a product of some integer with itself. What I explained, like 1, 4, 9, 16, and so on. Like 3 and 11 are now perfect square. Uh, that's pretty much catchable. So what we need to do is, first let me just copy this first along with the explanation, so that it's easy for me to explain you what it actually is. Okay, explanation, let's just put explanation at the top so that you can get what I'm trying to do. Also the second one as well. And I'm going to take an example that is like not as simple as the word two given, but I'll just show you because n is 13 and or 12 in this case, so we'll be doing something like a smaller number to explain you how it can be done, and more like it's easy for you to understand. All I'm trying to say is, all right, so at first what do we need to do is, like, if we have 12, so how we can get 12: 1 square plus 2 square, 1 square plus 1 square plus 1 square. Oh, all right, so if we do this, then we have to 12 ones. But if we go like 2 square plus 2 square plus 2 square, then we have to do it only 3 times, right? What better can be done? Can we do it any better? I guess yes. How? No, like it's 3 times, so it's obviously we have to go. Another way is like 3 square plus, or 3 square plus 3 square is going to be 9, 9, 10, 11, 12. 1 square plus 1 square plus 1 square, so that's 4. So that's not very wise to do that. The best we can do is to 2 square plus 2 square plus 2 square as given here. All right, what about 13? What about, let's just put it as in one place. Let me just put it in one place, and I'll just let it go here. And now I'm going to explain you for 13. So 13, how well can we do 13? 1 square into 1 square, that goes to 13 times. That's pathetic. But like, what else can we do? 2 square plus 2 square plus 2 square, 2 square plus 2 square plus 2 square plus 1 square. That's way better. That's 4. But can we do any better? Can we do any better? Yes. 3 square is 9 and 2 square is 4. That comes way down to 2. And this is how we're getting 2 here, and the last example we did was 3. Now, what else? So let me just remove it, and we are going to I'm going to explain how we are going to solve it in actual example, by taking an actual example and how we're going to solve it. So suppose I'm taking a number that's way lesser than 12 or 13. Let's suppose this is the number 6. So coming down to the algorithm, how we can do it. Algorithm. And if we suppose we have to take a DP array name DP, that's of length n plus 1. Remember, this is the n. This is the n. I wanted to I want to reiterate that again. So if you are confused, like what's n here, this is n. So we are, if n is 6, in this case, we will take a DP array of 7. So just storing all the states, what's the common law here? 1, 2, 3, 4, 5, 6, 7. And what do we need to do now? Uh, all we need to do is that we have all 7 states, and we are going to iterate it using we first step is the first step was creation of TP array. Second step is iterate from 1 to n. Iterate from 1 to n. And suppose iterate, let's suppose this is I, the variable that we are going to take from iterating 1 to n. And I'll set dp of I to infinite. And I'll tell you why I'm doing this. I'll tell you why I'm doing this. Like, I'm a psycho for doing this. No, this has very good logic behind it. Now, in secondly, that's there are two for loops working, and we are going to iterate j from 1 to root n. Iterate j from 1 to root n. Cool. But what it's going to do, now what we are going to do now, I'm going to tell you. We are going to do dp of I is going to be minimum of dpi, and second minimum of this, if you are not able to see, dpi, and remember, let me, if you are not able to see, let me just zoom in, here. Minimum of dpi, minimum of I minus j into j, I minus j into j, and we are going to assign whatever is the minimum. Remember, this is infinite every time you win this. If we've started from I and it's infinite, and we assign something that's minimum, it becomes it's stored in I, and then j will go from 1 to 2 to 3 to 4. Again, it's going to check what is minimum in the second index, in the third index, in the fourth index, and it's going to store whatever was least, and this is how you're going to do dynamically. And we're going to move from one state to another, to third, to the fourth, to the nth state, and we're going to check for each one, and this is how we are going to get the minimum steps that we are going to take to reach the number using just the squares. And this step is we are doing this is what we are doing to check for the squares of each number, like 2 or 4 or 9 or 16. Similarly, if you are at 9, any set, suppose like if we are at 3 and 9, and we want to check if j is 3, 3 into 3 is 9. And this is how we're going to know that supposedly 9 minus 9, which we are going to take whatever was at 0. At 0 was just 0, and we're going to plus 1 into it, and we're going to plus 1 also because we're taking one extra stage. That's why we are going to do plus 1 here. And that means we just need one step to go to 9. Just need one step to go to 9. Easy, easy. And now that we have like studied algorithm, let's just do how we can do it. how we can do the dry run. Take an example, and so let me just erase this all except this. uh, this was, and at the least the last step is that we are going to return we're going to return dpn we are going to return dpn, and all of this we're going to move it sidewards. Now we have our dp array 0 comma 0 comma 0 comma 0 comma 0 comma 0 comma 0 seven times, right? For 6 it's n plus 1 7. And what we need to do now is that for I equals to 1, the j needs to be less than 1. uh, uh, let's just take example and see, like dp for j in 1, j is going to be till 1 to root of n plus 1. Root of n is 1, so j is going to be 1, just 1. Not before, I don't know, not after that. Just a second. Yeah, 1, it's 1, so 2, so dp is going to be, like j is going to be less than 2, less than 2, or I'll just remove it and write it less than 2. I'll just write it less than 2, because to n root of n plus 1, root of n plus 1 is 2, and it needs to be less than 2. So dp of I is going to be minimum, and remember, if I we will first assign dp of I, dp of 1 as infinite, and then we'll check what is what is the lesser among infinite, and dp of I, which is 1 minus 1 into 1 is 1 square, so it's what is at 1 minus 1 0, and we're going to add 1 into it as well, and we are going to add 1 into it as well. So minimum infinite comma 1, so dp of I becomes 1. Voila, let me just cut it out and write it as 1. Alright, now again if we move ahead, uh, and I'll just pick this out all and delete it. Now for I equals to 2, again again j is going to be less than 2, because root of 2 is 1.4, like round it off and take it as integer 1. 1 plus 1, j is going to be less than 2. For dp of 2, we'll take, and this is going to be, I'm going to place this at infinite for now, and it's going to be minimum of infinite, and dp of I is 2 and j is 1. dp of 2 minus 1 into 1 and I forgot this again. 1 1 again plus 1, and so it's going to be minimum of infinite comma infinite comma 1 plus 1. So yeah, 2 is obviously minimum, so which is what. Now again you cut this out infinite and make it 2. That's how it is done. That's how it's going to be done. Now for 3, now comes the interesting part. No, not yet. We still need to go ahead a bit before watching the interesting part I was talking about. Okay, I'll just cut this out now. I'll just erase this and this and this. Alright, and this. So what do we need to do for I equals to 3? J needs to be less than 2 again, because 1.73 essentially is 1, and 1 plus 1 is 2, so we need to keep it below 2. For dp3, dp, and we need to, what do we need to do? Infinite it. We assign dp of phi3 is infinite at first. Let's just do it as infinite. How did you do in white? Oh, it's 2 as well. It's 2. We need 2. It's 1 and 2. And first, what do we have? Like, is I dp 3 minus 1 into 1. It's 2. dp of 2 plus 1. 2 plus 1 is 3. Minimum of infinite in 3 is going to be 3. So here we go, increment 1 again and make it as 3. Make it as 3. Cool. What else? What else? It's a bug, I think. Yeah. Now we are at 4. Let's just erase this, rub this again. I need to rub a few things out. Like always. Yeah, we're at 4. And when I equals to 4, j is less than 2. Not anymore. Less than 3, because in Q the root of 4 is 2. 2 plus 1 is 3. Less than 3, we need to go again. So you're right, I need to make 2 step, like we'll calculate this 2 times, means the second loop will run twice. So dp of 4, let's write it in white. dp of 4 minus 1 into 1. So j is 1 right now. So j is 1 right now. 4 minus 1, that's going to be 3. dp of 3 plus 1 is 4. But this will run again. This will run again. So this time it's going to be dp of 4. But instead of this 1, we'll cut this out and calculate again. Okay, I'll just write it as again here. So step 2, iteration 2, whatever you can call it, the second iteration of the second loop, dp of 4 minus 2 into 2 plus 1, or the 4, or the infinite. What is the smallest? What is the smallest among these 3? Infinite? No. 4? Maybe. But what lies here? 4 minus 0, 4 minus 4 is going to be dp of 0. And dp of 0 is 0 plus 1, 0 plus 1, 1. So 4, 4, 4, infinite, infinite, infinite. 4, 1. Now the 3 options we have is 4, 1, or infinite. And for that, for that, like for 1 and infinite, right, we have 1 as the least. So at this position, we have 1, not 4. So yeah, that's how it's going to be done. And again, I'm going to erase this out, erase all of this, just delete. And yes, so now if our I is 5, if our I is 5, now what? If I is 5, just switch to y, and then 5 minus 1 into 1, that's 4. 4 plus 1, dp of 4 plus 1 is 2. 4 plus dp of 4, there is 1, and 1 plus 1 is 2. So 2 and infinite, it's going to be 2. But again, we'll check for step 2, and for step 2, what's going to happen? This will become 2, this will become 2, this will also become 2. 5 minus 2 into 2, that's going to be 2 into 2 is 4, right? 2 is going to be 4. Am I going right at this? Yes. So for 5 minus 4 is 1, dp of 1 is 1, 1 plus 1, 2, 2, comma 2, comma 2, and 2 is the least. Simple as that. The reason that we are getting both at 1, if we check, like 1 was took just one position. For dp of 5 minus 1 into 1, that was dp of 4. 1, we can reach directly to 4 by having 2 square. And secondly, if we took the second, like we took the position at 2 into 2, that is dp of 1. dp of 1 is 0, dp of 1 is 1. So we can reach by having 2 steps. Maybe like if you are having problem, you can drop a comment like this. I know this is not easy to understand, and like if you need to just see that 2 into 2 is going to be 4, and we are standing at the position 5. So 5 minus 4 is going to be 1, and so we'll check what is it, state 1. At state 1, it's 1. So if we are at state 1, it's just 1. And this is how we can reach from 1 to 5 by jumping 4 times. So this is why again we are having 2 here. So 2, we will update it to 2, and again the same process. I'll not write it this time, I'll just update it as 6, dp of 6, 6, and minus 1 into 1, 6 minus 1 is going to be 5, 5 plus 1, 5 plus 1, dp of 5 is 2, plus 1 is 3, infinite plus infinite and 3. 3 is the least obviously, but we are going to take in the second iteration. For second iteration, we will make it as 2, make it as, it was 1 actually. And for 2, dp of 6 minus 2 is 4, 4 plus, like 4 my dp of 6 minus 4 is 2, dp of 2 is 2, dp of 2 plus 1 is again 3. So we will, so what's the minimum among the 3? The infinite that we actually took, and the like the dp of 1, the iteration from j. And j we checked for 1 and 2. With 1 we found 3, 2 we found 3, so 3, 3 and infinite. So this is going to be 3, and at the end, now we are done computing, we will return this 3. So that was it. And let's just code this up. dp equals to 0 plus 1, and then we'll run a loop for I in range 1, and we will assign dp of I equals to float infinite, and then run a loop for j in range 1 to integer of n into 0. And that's a square root. Don't be confused looking at that. A square root. Oh, I'll just put a comment here. That's trick. That's trick to find the square root. And dp of I is just equals to min of dpi, which we discussed at infinite. Because like even if dp was you can change to dpi, it's actually going to be the new value. Or even if if we are finding the minimum, and what I told was that dp, every time we are going to find dp of I, so we will find minimum of infinite to something like dp of I minus j into j, right? So we are going to put this dp of ij minus j here, and so the infinite I'm talking about is dynamically going to be stored here. And if it's dynamically going to be stored here, if you get something that's lesser than infinite, the infinite will just change its position. Infinite will no longer be there, and that's how dynamic is done. So if again anyone confusion, if anyone finds this, so this is resolved in code, and which was like already, that's intuitive, I guess, if you understand like how this minimum function works in Python or any other language that you code in. dp of I minus j into j, so dp of I minus j into j plus 1, and at the end we are going to return dp of n. So if we run this, let's see what we get. So yeah, the problem was that I should make it I the square of I, not square of n. So yeah, that was a catch from my side. You should like instead of doing this n, you should can even make it I. You should make it I, uh, not instead of n. So j must be from I to less than root of I plus 1. And if you do so and submit it, I guess this should run this time. Maybe it runs. So yeah, it's passing 67% memory and 58% time. So yeah, that was it. Like the taking your initial steps in DP. I'll see you in the next one.